Hello students, our next topic is the factors affecting resistance. First of all, let us talk about the cause of the resistance. What is the cause of resistance? Cause. Today we said that under the effect of potential difference, the charges of the electrons drift opposite to the direction of the applied electric field. So while drifting, there are number of free electrons, so they keep on colliding with each other. So the force due to the electric field gives the acceleration, and due to that acceleration, the electrons move, and on the way they keep on colliding with each other. So what is the cause of resistance? So collision of electrons when they drift. Under the effect of applied electric. So this field is due to the applied potential difference. So the collisions of electrons when they drift from one end of the conductor to the other due to the applied electric field. So this is the cause of the electrons, cause of the resistance. Sorry. So now the factors. So we have already derived this formula now. We have written here R is equal to M over N E square tau L over E. So from here we will get the factors on which the resistance of a conductor depends. So the first factor that affects is, I am now talking about the dimensions. So that is called as the length of the conductor. Length of conductor. So from here we get R directly proportional to L. R directly proportional means if the length of the conductor increases, then the resistance also increases. So in simple words, more length implies more resistance. So this is the first factor that affects the resistance. Second is area of cross section of conductor. So clearly from the formula, resistance is inversely proportional to the area of the cross section. So more area implies less resistance. So resistance is the obstruction offered to the flow of current. So due to the collisions, this resistance is there. So when the more cross section will be there will be less number of collisions, or the charges can pass easily from one end of the conductor to the other. So therefore, more area, less will be the resistance. Then the next is these all the things. N is the number of charges per unit volume. E is the charge. So number of charges. So resistance will depend on N. N is the material property. So it means the third factor that affects the resistance is the material. Is the material. So, but a good conductor will have more number of free electrons. So, more number of free electrons will be there. So, less resistance will be there. So, means good conductors will have less resistance. So, it is the property of the material. Bad conductors will have more resistance. So, from here you can make a note of this. Now, the fourth factor and one of the very important factors that I need to discuss. The fourth factor is the physical conditions. While talking about the Ohm's law, we said that the current through a conductor is directly proportional to the applied potential difference across the terminals of it, provided the temperature or other physical conditions remains constant. So means I want to talk about the physical conditions now. What are the physical conditions are related with this tau? The physical condition, and mainly I am talking about temperature. Temperature. So when temperature increases, the speed of flow of electrons will increase. So velocity increases. So with the increase in velocity, number of collisions. So when the temperature increases, the number of collisions also increases. Also increases. तो बेटे जब टेम्परेचर जो टेम्परेचर बढ़ेगा तो कोलिजन्स बढ़ जाएंगे तो नंबर ऑफ कोलिजन्स इंक्रीजेस एंड ड्यू टू इंक्रीज इन स्पीड है ना स्पीड जो बढ़ेगी तो फिर टाउ मीन्स एंड रिलैक्सेशन टाइम डिक्रीजेस एंड रिलैक्सेशन टाइम जल्दी जल्दी टकरा जाएंगे एक दूसरे के नाल रिलैक्सेशन टाइम डिक्रीजेस तो टेम्परेचर बढ़िया रिलैक्सेशन टाइम घटिया तो जो टेम्परेचर बढ़िया रिलैक्सेशन टाइम घट गया तो रिलैक्सेशन टाइम जो घट गया तो रेजिस्टेंस ऑफ द कंडक्टर विल इंक्रीज so means therefore resistance increases so resistance conductor का बढ़ जाएगा so means R is directly proportional to temperature we will say now or which is inversely proportional to tau so tau means the relaxation time so with rise in temperature the relaxation time decreases so due to which with rise in temperature the resistance increases so these all are the factors on which the resistance depends next is the temperature dependence so बेटे इत्थों ही ਆਪਾਂ ਨੂੰ ਇੱਕ ਹੋਰ ਰਿਲੇਸ਼ਨ ਮਿਲ ਜਾਣੀ ਹੈ so I hope that ਤੁਸੀਂ ਇਹਨੂੰ ਨੋਟ ਕਰ ਲਿਆ ਹੋਵੇਗਾ so I will continue this topic further because I want to talk about one more term that is called as temperature coefficient of resistance बेटे so we have seen that temperature affects resistance so temperature dependence of resistance so if some conductor have resistance R naught at 0 Kelvin so with rise in temperature resistance increases so let us say that the final resistance is R at T Kelvin So at T Kelvin, the resistance is capital R. Then it is observed that the resistance R naught is equal to R naught multiply 1 plus alpha T, 1 plus alpha T, where this T is the temperature. I am talking about this. So T is the temperature at which the resistance of the collector is capital R. So R naught is the resistance at 0 Kelvin. So from here, if I solve this, so this is equal to R naught plus R naught alpha T on calculations. What I will get is alpha is equal to R minus R naught over R naught multiply T. So this R minus R naught is delta R, means the change in resistance per unit original resistance R naught per unit original resistance and change in temperature and changing temperature. So this alpha is called as temperature coefficient, temperature coefficient of resistance. So alpha is called as temperature coefficient of resistance. तो ਉਹ ਵਾਲੇ ਮਟੀਰੀਅਲ ਜਿਨ੍ਹਾਂ ਦਾ ਅਲਫਾ ਲਾਰਜ ਹੋਏਗਾ, ਜਿਨ੍ਹਾਂ ਦਾ ਅਲਫਾ ਲਾਰਜ ਹੋਏਗਾ, ਤਾਂ ਅਲਫਾ ਲਾਰਜ ਹੋਣ ਦਾ ਮਤਲਬ ਕਿ ਉਹਨਾਂ ਦਾ ਜਿਹੜਾ ਰੈਜ਼ਿਸਟੈਂਸ ਹੈ ਉਹ ਚੇਂਜ ਹੋ ਰਿਹਾ ਹੈ ਵੈਰੀ ਕੁਇਕਲੀ ਵਿਦ ਰਾਈਜ਼ ਇਨ ਟੈਂਪਰੇਚਰ, ਵਿਦ ਰਾਈਜ਼ ਇਨ ਟੈਂਪਰੇਚਰ. ਸੋ ਨਾਓ ਵੀ ਕੈਨ ਡਿਫਾਈਨ ਦਿਸ ਅਲਫਾ. ਬੇਟੇ ਮੈਂ ਜਿਸ ਤਰ੍ਹਾਂ ਬੋਲ ਰਿਹਾ ਹਾਂ ਤੁਸੀਂ ਉੱਥੇ ਹੀ ਉਹਨੂੰ ਨੋਟ ਕਰ ਲਓ, ਬਿਕੋਜ਼ ਆਈ ਡੋਨਟ ਵਾਂਟ ਟੂ ਰਾਈਟ ਇਟ. So alpha, it is defined as the ratio of the change in resistance, the ratio of the change in resistance per unit original resistance and change in temperature. Do not confuse T with time. So it is temperature. In some books, this T is replaced by theta. So per unit original resistance and change in temperature. So this is what is called as alpha. But a unit of alpha is per Kelvin. Per Kelvin. So K raised to power minus 1 are its unit. You can make a note of this also. So for some conductors, alpha is positive. For conductors, alpha is positive, and for semiconductors, alpha is negative. So alpha negative means there will be decrease in the resistance for rise in temperature. So for thermistor, one material is called as thermistor. So thermistor is a device that is used to measure the small changes in temperature. So for thermistors, alpha is very large. Alpha is very large means that material used will be very sensitive to the temperature. But we need these two mainly. The materials for some alloys, alpha is very small. Alpha very small or near about zero. So means for these materials with change in temperature there will be no change in the resistance. So resistance nahi badlega. If alpha will be 0, so then R will be equal to R naught. So their resistance will remain constant for a long range of temperature. So these materials we will talk about later, but such type of materials will be used to make standard resistance or resistance boxes. So Constantan and manganese. You can make a note of this, but I will talk about the lecture in my next lecture about those. So those are the some materials, special materials. So constantan and manganese are the materials for which alpha is very very small or near about zero. That's why those materials are used for making the standard resistances. So these are the factors that affect the resistance. Now the factors that affect resistivity. The factors affecting resistivity. So, this is the formula for the resistivity. Rho is equal to. So, from this, what we get is the resistivity depends on the material only, because L and A are not there, means so resistivity does not depend on the dimensions of the conductor. So, these all are the properties of the material. So, it depends on, it is the property of the material. So, with change in dimensions, resistivity does not change. So, these all are the properties of the material. So, material more and implies less rho, less rho. N is a charge density. So, for conductors, less resistivity will be there. So, resistivity of conductors is less than the resistivity of semiconductors, and the resistivity of semiconductors is much less than the resistivity of the insulators. Insulators have more resistivity as compared to the conductors, and this also depends on the temperature. In case of conductors, with rise in temperature, tau decreases. So due to that, the resistivity increases. So resistivity for conductors, resistivity is directly proportional to temperature. So with rise in temperature, resistivity will increase because temperature is inversely proportional to tau, relaxation. So same conditions hai. So these are the two factors that affect the resistivity. Please remember, it is independent of dimensions. Dimensions of conductor. तो मीनस कभी कभी ना पेपर च पूछा जाता है, उन्हें कहना जी आप किसी कंडक्टर की लेंथ को डबल कर दिए तो फिर रेजिस्टिविटी का की फर्क पड़ेगा. तो आंसर इज देयर विल बी नो चेंज ऑन द रेजिस्टिविटी ऑफ द मटेरियल. सो दिस इज ऑल अबाउट दिस टॉपिक. अगला टॉपिक आप अगली क्लास डिस्कस करांगे. थैंक यू.